Hey friends, here we are in chapter 4 looking at matrices. We're going to do an introduction to matrices, section 4.1, algebra 2. As usual, we're going to take a look at this idea of matrix by first looking at our vocabulary. So, what's a matrix? A matrix is an array of numbers, and so you might have something like this where the numbers could represent really anything. Like this could be a listing of the number of the amount of money. I don't know why I just use money. The amount of pencils I found in my class on several days. So this could be like Monday, Tuesday, Wednesday, and Thursday. And this could be my first period class and my second period class. And so these are the amount of pencils that I found on the floor after class. And then this -8 could refer to the number of pencils taken out of my pencil bin. Something weird. I mean, literally, matrices can be an array of information for a variety of things. So that's what a matrix looks like. And this is just an example of what one can represent. So when we have a matrix, we refer to each of the numbers there as elements, okay? So this matrix happens to have 8 elements in it, and so that's an element. When we talk about the dimensions, it really is a way for us to describe what's happening or what's the shape of our matrix. So the description that we talk about when we're talking about the dimensions is we would usually use M by N. So M refers to the number of rows and N refers to the number of columns. All right, so now that we have this down, let me go ahead and highlight this. You should be able to tell me what the dimensions of this matrix is. So we start off with the number of rows, 1, 2 rows. So this is a 2 by how many columns? 1, 2, 3, 4. 2 by 4 matrix. A row matrix is a matrix with just a row of information. So you might have some elements A, B, C, D, but that's it. The row, there's only one single row and as many columns as you need. So what you'll find is that a row matrix will be a 1 by n, right? One row and however many columns. A column matrix, on the other hand, will be a single column. So your arrangement of elements would look something like this. And in this case, our row would be whatever number of rows there are by 1. And so a square matrix, let me put a little arrow here. A square matrix would be a matrix that looks like a square, often called an n by n, because both the length and the width, or the number of rows and the number of columns, are the same. So n by n, whatever, that's what we'd have. So the zero matrix is a matrix where you'd have some m by n matrix, but all of the elements are 0, all right? So that would be an example of a zero matrix. And finally, the idea of equal matrices. The idea of equal matrices is basically this. If you've got two matrices that are equal, a couple things must be in place. First, both matrices must have the same dimension. And each element has its equivalent in the same position. So an example of equal matrices would be the following two matrices here, where notice that -7 is the same here. If I tell you that these two matrices are equal, every element, the sizes must be exactly the same, and each element must have its pair, its equivalent in the same position. And so if these two matrices are equivalent, I know that A must equal 5 and B must equal 1/2. And that's it for vocabulary. Let's get to some examples. Here in example 1, we're going to organize our data into a matrix. Sharon wants to install cable television in her new apartment. There are 2 cable companies in the area whose prices are listed below. Use a matrix to organize the information. When is each company's service less expensive? So let's organize our information. So MC standing for Metro Cable and CC standing for Cable City, we were able to put them in just organize them in a way that I can kind of compare each of their services. So basic service, here's the two different prices. Standard service, one premium channel versus two versus three premium channels are represented here. This is basically all we need to do to make this matrix. Now we can use this information to quickly determine whose prices are better in each category. And so I'm going to use a highlighter to just highlight that. So I'm going to highlight in red the better price. So I can see here they have a better price here, better price here. Uh-oh, that's not better price. There's better price for them, not us, right? And better price. So I might choose based on my analysis that Cable City is less expensive overall. Here in example 2, we're to state the dimensions of matrix B. Notice B is a capital letter, and that's generally how we name matrices. And so we're going to name the dimension. So what's the dimension? Do you remember? Do you remember? Without looking back, remember that M by N is the way we describe it, and M stands for the rows, and C stands for the columns. I always honestly forget this. Every time I teach it, like I forget which one comes first, but I kind of make myself remember that the rows and the columns are out of alphabetical order. Because a lot of things in math are alphabetical order, like X, Y, anyway, ordered pairs, abscissa ordinate, like a lot of words like that that require order. Often are alphabetical, and I'm like, okay, awesome, and this one just does not work. So that might be a way that you remember. Oh, anyway, so how many rows? 1, 2, 3. We've got 3 rows and 2 columns. This is a 3 by 2 matrix. Earlier on, we did talk about the fact that when you have equal matrices, then you know that each element in whatever place that element is in, those two elements have to equal. So we're given an opportunity to solve an equation in this matrix situation. These are 2 column equations. This is just 2 elements on top of each other, and here's 2 elements on top of each other. So what we know is that since y is in this position and x and 6 minus 2x is in that position, those guys are equal, and 3x has to equal, 3x has to equal to 31 plus 4y. With that information, I'm going to set up our situation. Now that the equations are written, I realize I've got 2 unknowns and 2 equations, so I know I can solve it with substitution or elimination. It's not really organized for elimination. Y is by itself. I'm going to go substitution on this bad boy. So I'm going to take this y value here, which we see located on the first equation, and I'm going to substitute this value right in here. So I'm going to substitute that, and here's the rewritten equation with the top equation, with the second equation rewritten with the top equation tucked in. So I solve like I always do, right? Distributive property is called for here. So this is plus 24 minus 8x. Joining like terms together, I'm going to move the 8x over to the other side. And so I get 11x is equal to 55. And you got it. X has to be equal to 5 because I'd be dividing both sides by 11. I'm going to take that 5, I'm going to plug it right back into my equation that I have solved for y. And when I do that, I get that y is equal to 6 minus 10, or negative 4. Let me make that better. And so x and y values can be written as 5 and negative 4. And that's really it. That's it for our intro to matrices. That's it for this lesson. And look forward to talking to you soon. Let me know if you have any questions, and we'll be talking about matrices for a little while. All right, take care now.